Hello, my name is Anna Villareal, and I'm a student in the Physics 1415 class at Mountain View College, which took place this past winter 2015. Today I'm going to discuss a project that I worked on, which is called Building an Electric Motor. In order to do this project, I used the following materials: modeling clay, a marker, a D battery, electrical tape, 22G insulated wire, paper clips, a magnet, a hobby knife, and a pair of pliers. The base of the motor is a D battery, which is held in place by the modeling clay. In order for the motor to work, there needs to be a flow of electrons. To move the electrons from the positive to the negative side, I used 2 paper clips and attached each of them to the ends of the battery with electrical tape. To complete the circuit, I used a coil which I made using the wire, which I wrapped around the marker approximately 8 times, and I added extra pieces of wire to help it rest straight across the paperclip connectors. I scraped off the plastic coating from the wire using a hobby knife in order to allow connectivity between the paperclips and the coil. This completed the circuit. When the coil is turned, it should be able to spin freely. In order to keep it spinning, however, a magnet is introduced. By adding the magnet, we have an acting force on the coil, allowing for it to continue to rotate. While I was building this motor, there were several attempts that I made to get it going. My first attempt, or one of my first attempts, was to use this copper wire, which is insulated with rubber, and remove half of the covering in order to still expose the copper that was lying underneath, but to keep some of the insulation on. When I tried this, it did not work. So I tried making another coil with all of the insulation removed, thinking that this would increase my connectivity. However, this did not work either. I then tried using this steel coat hanger, which I thought would work because it had greater magnetism, but it was far too heavy and it did not work. Which brought me to the use of this wire that I have here. But when I used it, I used a single magnet and the motor did not work. I thought perhaps the magnets needed to be of a stronger strength, so I added multiple magnets together. This still did not work. So I found an extremely strong magnet and applied this to the battery, which I will do now. It's right underneath the coil, as you can see, and everything is connected. I have my paper clips connected to each of the terminals of the battery, and I have the coil with the metal exposed, which is completing the circuit. I will now demonstrate my motor. It's possible in order to give a free flow to the coil. Okay, let me try it again. As you can see, I get a really good spin out of this coil, but unfortunately, the coil does not continue moving. Even though I believe everything is in place for the motor to work, I could not get it to continue spinning no matter what I did with any of the coils that I made or with any of the magnet configurations. Let's try one more. As you can see, it just turns a few times and then slows to a stop. So, that said, this project is very interesting to me. However, it was largely unsuccessful. So this completes my presentation of my electric motor.